Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject of physics, class 9, chapter number 8, motion. Topics 8.4 Graphical representation of motion. The last class we discussed about measuring rate of motion. Under this we learnt what is meant by speed, velocity, acceleration. Now we are going to see the graphical representation of motion. You know what is meant by graph? Why we want to plot a graph for represent a motion? Because graph provide a convenient method to present basic information about a variety of event. Using graph, we can say we can say the information very accurately. To describe the motion of an object, we can use line graph. We know that there are the different type of graphs are present, bar graph, line graph, and etc. So to describe the motion of an object, we use a line graph. In this case, line graph shows the dependence of one physical quantity such as a distance or velocity on another quantity such as a time. If you take a speed, you know that the speed equal to distance by time. Here the distance is one physical quantity, time is another physical quantity. So one physical quantity must dependent on another physical quantity. We have two type of graph. One is a distance time graph and another one is a velocity time graph. So first we are going to discuss what is meant by distance time graph. The change in position of an object with the time can be represented on the distance time graph adopting a convenient scale of choice. So why we want to draw a distance and time graph? Using distance time graph, we can calculate the speed of the object at any instant of time. So in this graph, time is taken along the x-axis and the distance is taken as a y-axis. So you have to take a graph and x-axis time is represented in the x-axis and distance is represented in the y-axis. Distance time graphs can be employed under various conditions where object move with uniform speed, non-uniform speed remains at rest. So when we divide distance by time, we get speed. So there are the different type of speed. One is uniform speed, non-uniform speed, and the object remains at rest. So we can get three type of graph under the distance time graph. So before going to draw a graph, you have to take a graph sheet, pencil, and scale. This is a tabular column for time, distance of different object. Here I took three object A, B and C and time. The time is represented in minute and distance is meter. So the time 0 minute, 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, 6 minute. When the time is 0, the object A traveled the distance 0 and B also 0, C also 0. When time is 1 minute, the object A covers 10 meter, object B cover 1 meter, object C cover 30 meter. When the time is 2 minute, the distance the object A cover 20 meter, object B 4, object C 30. So for this reading, we are going to draw a graph. First, distance time graph for uniform speed. How I am saying that uniform speed? See here the time interval is same and distance is same. The time interval is 1 minute for all, and the same as the distance is same for all the readings. So here the object cover equal distance and equal interval of time, so we can say that is uniform speed. You have to take a graph sheet and draw a x-axis and y-axis, then write the time is in the x-axis and distance is y-axis. And see the reading, the time in minute, so you have write here minute, and distance in meter, so you have to write meter. See the value of the time, 0, 1, 2, 3, 4, 5, 6. So I written 1, 2, 3, 4, 5, 6, 7, 8. And see the distance, the minimum distance is 0, maximum is 60. So I take 10, 20, 30, 40, 50, 60. Then you have to mark the point in the graph. When time is 0, the distance is 0. So this is the point. When time is 1 minute, distance is 10. So 1 minute 10. When time is 2 minute, the distance is 20. So you have to mark here. When time is 3 minute, the distance cover 30. Then 4 minute 40. 5 minute 50. 6 minute 60. So you have to mark the point in the graph. Using this reading, you have to mark. The next step, you have to join all the dots. So we get a straight line. So for uniform speed, we get straight line graph. The next, you have to take any 2 point in the straight line. Here I taken point A and this is a B. See here, this is point A and this is point B. You can choose here also A, B. It's anywhere in the line you have to choose any 2 point and give a name A and B. And then you have to draw a perpendicular line to x-axis and also y-axis. So here I chosen A in a perpendicular line I drawn, and in a y-axis perpendicular line. The same also in a B point I have to draw a perpendicular line to x-axis and also y-axis. See, it was clearly shown here. You have to draw a perpendicular line along x-axis and also y-axis for both the points. The next step, you have to draw a triangle for like that. Then you have to calculate speed. You know the formula, speed equal to distance by time. The distance is represented by s and time is represented by t. Here I written delta s and delta d. That is nothing but the delta represent difference. So see here, this is a time and this is a distance. We can write the first point t1 and second point t2, the same as the first point s1 and second point s2. So in a s delta s we can write s2 minus s1, delta t we can write t2 minus t1. Then you have to see the value s2. What is the value of s2? s2 is 40, so write 40. What is the value of s1? s1 value is 30, so 30. What is the value of t2? 4. Here write 4. What is the value of t1? 3. So 40 minus 30 and 4 minus 3. 40 minus 30, we get 10. 4 minus 3, we get 1. So 10 by 1, we get 10 meter per minute. So this object cover 10 meter in 1 minute. If you calculate here, the same value we get. So from this we can say that this graph give uniform speed. Are you understand how to calculate the speed from the graph? You have to choose any 2 point in the line, then you have to draw a perpendicular line, then you have to take a values and substitute it. Finally you will get the speed value. From this we can say that this object covers equal distance at equal interval of time, so we get uniform speed. The next one, this is a graph for uniform speed. So when you are drawing the graph, you have to draw x-axis and then write time in minute. You have to represent the unit also. Then y-axis write distance in meter. Then you, after completing the marking point in the graph, you have to write the scale. If you take x-axis, the 1 centimeter is 1 minute, and y-axis 1 centimeter is 10 meter. The scale is very important. In the distance displacement, I given some numerical related to distance and displacement. You know that they given the value of 1 centimeter, 1 kilometer, 1 meter. The same thing you have to give here also. The next one we are going to see distance time graph for non-uniform speed. So non-uniform speed means you take the object B, because this object cover unequal distance in equal interval of time. So see the time difference 1, 1, 1, 1, 1. But see the distance 1, 3, 5, 7. So this object cover unequal distance and equal interval of time. So this is called non-uniform speed. The same thing, you have to take a graph and draw x-axis and y-axis. Then write time in x-axis, distance in y-axis, and then mark the point. This is a tabular column. Using this tabular column you can mark the point. See here, I marked here at time 0 the distance 0. So first point here, time 0, distance 0. So this is 0. When time is 1, distance also 1. You have to choose the value. Here the time is 0 to 6, so I written 0 to 6. Here the minimum value, minimum value is 0 and maximum value is 36. So I took 5, 10, 15, 20, 25, 30. So 2, 4. So I marked 2, 4 and all other readings I marked. I get like this. When I joined the point, I got in this safe. So this safe represent that non-uniform speed. The object moves in non-uniform speed. When when we are not get straight line graph, that graph shows that the object move in non-uniform speed. So time in minute, distance in meter, we get in the safe graph. The next thing, you have to choose any 2 point in this line. So I have chosen A here and B here from this line. I drawn the perpendicular line to x-axis and also y-axis. The next step, I have written S2 here, S1, T1 and T2. You know the speed equal to delta S by delta T. The delta S we can write S2 minus S1, and delta t we write T2 minus T1, and the value of S2 25, S1 15, so 16, 25 minus 16, the value of T2 5, the value of T1 4, so 5 minus 4, 25 minus 16 we get 9, and 5 minus 4 we get 1. So the speed equal to 9 meter per minute. That means the object cover 9 meter in 1 minute. If you take here A and B, then we will get different value. So from this we can say that the object does not cover, does not move in uniform speed. The next one, distance time graph for object at rest. When we say the object at rest, if you take any object at a time 10 o'clock, the object is same place. 11 o'clock also same place. 12 o'clock also same place. So from this we can say that according to the time, the position of the object does not change. That means object at rest. Here I took at a time 0, not 0, that is 30. Time 0 also 30, 1 also 30, 2 also 30, 3 minute also 30. We have to draw a graph. The same thing, you have to take a graph and draw a x-axis and y-axis. Then mark time in minute x-axis, distance in meter y-axis. And see here 30. At times 0, you have to choose the value 0 to 6. So I written 0 to 6. And here the maximum value is 30. So I took 10, 20, 30, 40, 50. So first reading time 0, the value of distance is 30, not 0. So here I marked. Time 1 minute, the value of distance is 30. So 1 minute 30. In a 2 minutes also 30, 3 minutes also 30, 4 minutes also 30, 5 minutes also 30, 6 minutes also 30. So I marked the point, then I joined the line. So here this graph shows that the object is at rest. Now we want to calculate the speed. How to calculate the speed? You have to choose any 2 point in the line. So here I choose A here and B. You have to draw a perpendicular line to x-axis and also y-axis. And speed equal to delta S by delta T. In a delta S we can write S2 minus S1. Delta T we can write T2 minus T1. The value of S2 and S1 is same point, that is 30. So 30 minus 30. And the value of T2 and T1, the value of T2 is 4 and T1 is 2. So 4 minus 2. 30 minus 30 is 0. 4 minus 2, 2. So 0 by 2, 0. So the speed is 0 means the object does not move. So from this we can say that object at rest. Dear students, are you understand what is meant by the object at rest? When the speed of the object is 0, we can say that the object is at rest. So see these 3 different type of graph for reading. Here I took A object, B object and C object. When I draw a graph between time and distance, when I draw a graph between time and a distance for a object, I get straight line. Time and object B, I get curved line. Time and object C, I get a straight line like that. So this graph shows that object is moved at uniform speed, and this graph shows that the object moved at non-uniform speed, and this graph shows that object at rest. So this is the difference between these two graphs. When the object cover equal distance in equal interval of time, we get uniform speed. When object cover equal interval of time and unequal distance, we get non-uniform speed graph. When the object cover same distance, we get object at rest. So this is the difference between these three graphs. So conclusion, how to calculate a speed from a distance time graph. So that when we divide the distance and the time, we get only the speed. So we can calculate speed from the distance time graph. What we can calculate from the speed and distance and time graph? We can calculate speed from the distance time graph. In a gradient, change in distance by change into time. That is, a change in distance is a delta S, change in time is delta T. And you know that S2 minus S1, that is distance at B, distance at A. Time at B, time at A. See here, it was represented here. Here I chosen the point. This is B, distance at B and distance at A. The same as time at B at time at A. So here 70 and 10, 6, 3. 60 meter by 3. So we can get 20 meter per second. That means the object cover 20 meter in second. So how to calculate a speed? From this equation we can calculate a speed for different graph. And see here, when we get the graph in a straight line, that motions are said to be uniform motion. Here distance remains constant with the time. That means 30 meter, 30 meter, 30 meter we learnt now. So the distance remains constant according to the time. The distance of the object does not change. That means here see, the time is increasing 1, 2, 3, but the distance of the object is not increased. But this graph also called uniform motion. Here equal distance is covered in equal interval of time. How we can say that? Because here time also increasing, the time is increasing, according to the time distance also increased. So we can get straight line graph. Here unequal distance is covered in equal interval of time means we can get a graph in this way. That means unequal distance but equal interval of time. Maybe unequal distance is covered in equal interval of time. Sometimes we get the graph in this way. So here increasing, this is increasing non-uniform motion, this is a decreasing non-uniform motion. When the graph line is not a straight line, that motions are said to be non-uniform motion. So what is the difference between these two? Here this is increasing non-uniform motion, this is decreasing non-uniform motion. This is your homework question. You have to draw a graph for the given values. The time is given. There are the three objects, object A, object B and object C, and I given the value of distance for different object, you have to take your graph sheet and mark the point, then you find the speed for this graph. So this is your book content. See topic 8.4 graphical representation of motion. And there are the two type of representation of motion. One is a distance time graph, and see we have three distance time graph for uniform speed, non-uniform speed, and remains at rest. So the first, they shown distance time graph for object with the distance time graph of an object moving with uniform speed. So we get a straight line. So this straight line, from this straight line we can say that the object is moving with uniform speed. And I discussed about how to calculate the speed. We know that s2 minus s1, t2 minus t1. The v represent for the speed. And this is a tabular column for non-uniform speed. See here, the time interval is 2 minute 2 second and 2 second 2 second, but it cover unequal distance. So this is a distance time graph for non-uniform speed. For non-uniform speed we get a graph in this shape. So the same as how to calculate the value of v. We can calculate the value of v using the formula t2 minus t1 and s2 minus s1. So the next class we are going to see the velocity time graph. How to calculate the value of the speed of this graph? You have to choose any 2 point from this graph and draw a perpendicular line. You can take this is a t2, t1 and t2. The same as you have to take s1, s2. From this value we can calculate the speed of the object. So this is your book content. I hope you understood how to draw a distance time graph for uniform speed, non-uniform speed and object at rest. In your book they don't show the object at rest, but I discussed object at rest in the video. And also I given some numerical sum to you. You have to do that, then only you will understand the difference between uniform speed, non-uniform speed and object at rest. Thank you for watching.